We now discuss the solution of a problem from the section Linear Algebra, which is related to the dimension of a given vector space in the question. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022, and it is from the section B. The given question is, suppose A is a real n by n matrix of rank R. Let V be the vector space of all real n by n matrices capital X such that A multiplied by capital X is equal to 0. What is the dimension of V? We are given four options. Option 1, R. Option 2, NR. Option 3, N square R. Option 4, N square minus NR. We have capital A is a real square matrix of order n of rank R. We are also given V is the vector space of all real n by n matrices capital X such that A multiplied by capital X is equal to 0. Required to find the dimension of V. We now discuss the solution of the problem in detail. Now, we support our answer through an example. That means we go by an example. We take capital A to be a 3 by 3 matrix as 1 0 0 first row, 0 0 0 second row, 0 0 0 third row. And the order n is 3. Its rank obviously is 1. Agreed. Now, V is the set of all those 3 by 3 matrices capital X with real entries such that Ax is equal to 0. Let us take capital X to be Xij 3 by 3 matrix where Xij the entries are real numbers for 1 less than or equal to I, comma j less than or equal to 3. Agreed. Now, Ax is equal to 0 matrix, 3 by 3 matrix is if and only if capital A the matrix multiplied by capital X the matrix is equal to 3 by 3 0 matrix. Multiply. If you multiply, you will get the first row x11, x12, x13 and zeros elsewhere. If you multiply this one, you will get the first row only. And that is equal to the 3 by 3 0 matrix. Here we have written 3 by 3 0 matrix. Two matrices are equal if and only if their corresponding entries are equal. So this will implies and implied by x11 is equal to 0, x12 is equal to 0, x13 is equal to 0, and the remaining entries are all arbitrary. How many remaining entries will be there? 9 entries are there, in which 3 entries, the first row 3 entries are 0. The remaining are real numbers which are arbitrary. They can take any values. So, V is equal to the set of all capital X is equal to 3 by 3 matrix. First row 0 0 0. Second row x21, x22, x23. Third row x31, x32, x33, where these xij's are real numbers. For I is equal to 2, comma 3, for j is equal to 1, 2, 3. They are arbitrary. Right. We have V, we have written, and in which capital X is a set of all those matrices in which 6 entries are arbitrary. Therefore, the dimension of V over R is 6 because the 6 entries are arbitrary. So the dimension is 6. Now the dimension we have obtained. Can this be R? R is 1 only, so it cannot be R. NR, N is 3, R is 1, it is 3, so it cannot be NR. N square R, N square is 9, R is 1, 9, so the dimension is V, it cannot be N square R. But if you put N is equal to 3, R is equal to 1, N square minus NR is 6, so it tallies with this answer. Therefore, the answer to this question is option 4. Now, note that for N is equal to 3, R is equal to 1, dimension of V over R is not R because it is 1 only. Dimension of V over R is not NR because NR is 3. And dimension of V is not equal to N square R because N square R is 9. But the dimension of V over R is N square minus NR. So the answer to this question is option 4. This is one method of doing this question, and many students practice this and they do it in the examination. Within 3 minutes they will get the answer. It's okay. They do it and they arrive at an answer. But however, I wanted to give you a proof. The dimension of V is N square minus NR. The general proof I will give you in the next slide. So, we now give a proof for that. Given A is a n by n matrix with real entries and the rank of A is R. It is given. And given V is the set of all those n by n matrices with real entries such that AX is equal to the 0 n by n 0 matrix, and it is given it is a vector space over R, and it is required to find the dimension of V. Right. Let us write down capital X is that n by n matrix with the real entries as the matrix with n columns x1, x2, xn, where x1, x2, xn are columns of X. These are the columns of X, and let us write xi, the column vector as the column vector x1i, x2j, x3j, xr, x1i, x2i, x3i, xri, etc., xni as a column you have to write, but I have written the row vector to the transpose, that is the column vector you will get, and for I is equal to 1 to n. Agreed. So now Ax is equal to 0 will implies and implied by. Now multiply, so it will be Ax1, Ax2, Axn and 0. So Axi is equal to the 0 vector n, the column vector, n column vector, 0 n by 1 means column vector. Axi is equal to column vector 0 column vector for 1 less than or equal to I less than or equal to n. Now see what is this? What is this? This is our a system of homogeneous linear equations, n linear equations in n unknowns, where the coefficient matrix capital A has rank R. Then we have studied and we know that this system, this homogeneous system is anyway consistent, and wherein n minus r variables are arbitrary. A is a n by n matrix and the rank of A is R. N minus r variables are arbitrary. N minus r variables of xi are arbitrary. Agreed. And hence this homogeneous system accepts infinitely many solutions. Note that Axi is equal to 0 n by 1 for each I is equal to 1 to n is a homogeneous system of linear equations, and we have rank of A is R which is less than n. Then n minus r variables of xi are arbitrary and hence admits infinite number of solutions. So for each column, n minus r variables are arbitrary. If we take all these columns, Ax consisting of n columns, in each column n minus r variables are arbitrary. Ax is equal to 0, in which capital X is that n by n matrix will have n into n minus r variables are arbitrary. Because n columns are there, in each column n minus r variables are arbitrary. So Ax is equal to 0 n by n in this V. N into n minus r variables, in the n into n minus r variables of x are arbitrary. So thus Ax is equal to 0 n by n will imply n into n minus r variables of capital X are arbitrary. Since each xi has n minus r arbitrary variables and there are n columns, therefore n into n minus r variables of capital X are arbitrary. So this will tell you that the dimension of V is n into n minus r. That's the proof, the general proof of that result, and hence the answer is option 4. So that's your answer. Dimension of V is n into n minus r. Remember, it will help you sometimes while working out some of the problems. So that is the detailed discussion of the solution of the problem from the section linear algebra, which is based on the dimension of a given question in the examination. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.